Thank you for joining us for today's Adult Education Senior University, the Great American Eclipse and You session with presenter Jessica Warren. A little bit about Jessica. Dr. Warren earned a Bachelor's of Arts in Physics and Astronomy from Vassar College and a PhD in Astrophysics from Rutgers University, where she focused on X-ray spectra of supernova remnants. Since then, she has focused on teaching and is a lecturer in physics and astronomy at Indiana University Northwest. Her current research interests include studying light pollution and solar energy. Jessica is active in science outreach, having judged for local science Olympiad competitions, hosted astronomy observing nights, and visited local schools. Thank you for joining us today. You can go ahead and start sharing whenever you're ready.
Thank you very much for coming today and for having me. So I'm really excited to talk about the Great American Eclipse 2024 edition. I'm going to start by talking about what an eclipse is and why they are cool, and this one in particular is so cool, as well as what we can do to safely view eclipses, different methods that we have. And then I will get into sort of the nitty-gritty of, I'm going to talk about Gary and what we can expect to see in Gary. And then I'm also going to talk about Indianapolis, which is in the path of totality, and what we could expect to see in the path of totality. And then I have a few other tips, and then I'll open it up for questions for anybody. So let's get started. So the first thing I actually want to do, I'd like to ask you to maybe share an experience that you had watching a past solar eclipse. So thank you all for sharing. I think just what that illustrates, what I wanted to get across to people, is that these are very memorable events. If you've seen one, you remember it, even if you didn't know exactly that that's what you were looking at. These are images from various places for the 2017 eclipse. In JPL, that's in California, and then Oregon, and then telescope images of the actual progress of the eclipse from Oregon as well. And so this eclipse is also set to be a very memorable one and very memorable experience. So what is a total solar eclipse? Most people realize that the moon orbits the Earth. And as the moon orbits the Earth, both of them are in turn orbiting the sun. So sometimes the moon will pass in between the Earth and the sun, just like in this picture here. And when that happens, the moon is in its new phase, and the sun casts a shadow of the moon. So what happens is the moon's shadow, when they all line up just nicely like this, the moon's shadow will fall over the surface of the Earth. There are two parts to every shadow, and you can actually see this I don't know if it's still sunny outside right now or not, but if you go outside and you look at your own shadow, if you look carefully, you'll see that the edge is slightly fuzzy. And that's because you're looking at the two parts of your own shadow, the umbra and the penumbra. So the umbra is where all the light from the sun is blocked. And so it is the darkest part of the shadow. And the penumbra is where only some of the light is blocked from the sun. So if you happen to be within the umbra of the moon's shadow on the Earth, then you will experience a total eclipse. If you are within the penumbra of the moon's shadow, you will experience a partial eclipse. And you can see this image is, of course, not to scale, but it does illustrate that the penumbra is a much wider region than the umbra. The umbra is just this little dark circle on the Earth, whereas the penumbra is quite a bit bigger circle. So this is why some places will see total and some will see partial. Now, if you think about this, if you've heard about moon phases, and I said this is the new phase for the moon, then you might realize that we experience a new moon every month, sometimes more than once a month. because of the moon cycle. But we don't have solar eclipses every month. So why is that? Well, the answer has to do with the fact that the moon's orbit is actually tilted a little bit with respect to the Earth-Sun line. So this graphic tries to illustrate that. So here is the sun, and the blue ball is the Earth, and the large circle is the Earth's orbit. The little yellowish ball is the moon orbiting the Earth. So these are the small circles are the moon's orbit. And you can see from this that the moon's orbit is tilted a little bit with respect to the Earth-Sun line. So what that means is that most of the time we get a new moon, but because the moon is in between the Earth and the sun, but the moon is slightly above or slightly below the Earth so that its shadow doesn't hit the surface of the Earth. And that's what happens most of the time that we get during the new moon. But because we have this sort of intersection of these two planes, the orbit of the Earth and the orbit of the moon, there is a line where they cross, and that's illustrated by this pink line here. So if we get lucky, such that, and this line is called the line of nodes, and if we get lucky that the new moon falls on that line of nodes, then we will have a solar eclipse, because then the Earth, sun, and moon are all lined up exactly in line with each other, and the shadow will fall on the surface of the Earth. So it doesn't happen every month, but believe it or not, solar eclipses actually happen somewhere on Earth 1 or 2 times a year, sometimes even more. They're not always completely total solar eclipses, but they do happen fairly often. We don't see them a lot because most of the surface of the Earth is still uninhabited, right? It's mostly water. There's a lot of desert, Antarctica, right? A lot of places where people don't live. So even though solar eclipses themselves happen a couple times a year, they don't always happen in places where people can access them. Okay, so that's what an eclipse is, but why do we now have total solar eclipses? So this one, I want to use sort of a scale model here. So I brought this, this is the same as I have a picture of here. But basically what I'm gonna do is I'm gonna take the Earth and I'm gonna shrink it down so that it's this little ball 1 inch in diameter. So it's 1 inch in size. If I shrink the Earth down to be 1 inch in size, then the moon gets shrunk to be 1/4 inch in size, because it's about 1/4 the size of the moon, of the Earth, excuse me. So on this scale, you can see how small the moon is in comparison to the Earth. Now in distance, okay, this is a standard yardstick. The moon is about 30 times the Earth's diameter away, so 30 inches away from the Earth. So if we take the entire Earth and shrink it down to be 1 inch in size, then the moon is 30 inches away. And think about that. If we're traveling, the Apollo astronauts took several days to travel to the moon, just this distance. So this is quite far in actual reality. Okay, so this is the moon and the Earth. How about the sun? So I'd like to sort of get a show of hands, and you can raise your hand in Zoom as well. But just a show of hands, how many of you think that if the Earth is 1 inch in size, then let me just put this down. If the Earth is 1 inch in size, how big should the sun be? Should it be at least as big as a basketball? What do you think? Yes or no? Raise your hand if you think it should be at least that big. Okay. Does anybody think it should be bigger than that? Like, let's say something like, I don't know, what is that, 3 feet across? Yeah, you think it should be 3 feet across? Okay. How about bigger, like the size of my arms outstretched? Does anybody think it should be that big? Yeah? 1, Okay, does anybody think it should be bigger?
Yes.
Yes. Yes, you're right. On this scale, where again, the Earth is 1 inch in size, the sun would be a ball 9 feet in diameter. So that's way more than I can reach, right? So 9 feet in diameter would be the sun. So now let's think, oh, I lost my moon, it fell. About distance. If the moon Earth distance is 30 inches, how far would I have to take my 9-foot ball to place it at the correct distance from the Earth? So how many of you think I should take my 9-foot ball and go like just right outside the building here? Farther than that? Okay, how about if I go maybe across the street or to the main parking lot on campus? Yeah, maybe farther. Okay, so the answer is 325 yards, which is 3¼ football fields. So quite a long distance away. It's about 1,000 feet. So the sun is vast, right? It's vast in size and it's vast in its distance from us. What this means, though, is that we experience a true cosmic coincidence. The sun is about 400 times bigger than the moon, but it also happens to be about 400 times farther away. This means that those two things combine to make the sun and the moon appear to be the same size in our sky. So they look like they are basically cover the same angle in the sky. This is a huge cosmic coincidence. You know, 1 billion years ago in Earth's past, the moon was actually much closer to the Earth. And 1 billion years in the Earth's future, the moon will be much further away from the Earth. The moon is actually gradually moving away from us. And so we live in a time when they happen to be about the same size in the sky from our point of view. So that is why we have total solar eclipses, because we sort of live in this lucky cosmic coincidence time. There are no other planets in our solar system that experience this phenomenon. All right, let's get down to the April 8th eclipse now. Why is this a big deal? There are many reasons, but I've picked a few. So this particular eclipse on Monday, April 8th, 2024, covers quite a large chunk of North America. So I've shown this here. This is from the website greatamericaneclipse.com, which is a great resource. You can see it starts in Mexico, travels through a good chunk of the United States, and then up into Canada as well, into the Maritimes. The path covers an area that includes about 32 million people live within that path of totality. And then further 10 or more major metropolitan areas are within a 200-mile distance from the path, so an easy couple of hours drive. So this eclipse has the potential to be one of the most watched events in North America and potentially the world in terms of an eclipse. So that is a really cool thing that this is, you know, it covers such a large range. So many people have access to it that it's you know, not just a local phenomenon, but a national and even global phenomenon. Another thing that makes this eclipse a big deal is that solar eclipses for a specific location are very rare. So even though solar eclipses themselves occur a couple times a year somewhere on Earth, for your specific location, on average, you will only get an eclipse once every 375 years. Now that's an average. There were some places that are going to experience the 2024 eclipse that also experienced the 2017 eclipse. So that's a 7-year gap, which is very rare. But places like, so Gary last experienced a total solar eclipse in the early 1800s. And it won't again experience a total solar eclipse until 2099. Indianapolis will experience this 2024 as a total eclipse. But the last time Indianapolis saw a total eclipse was in the early 1200s. So it's been a long time. And again, for a specific location, these eclipses are very rare. So if you happen to live in the path of totality or are very close to it, you're lucky. Another reason why this particular eclipse, the April 8th eclipse, is potentially extra exciting is because it occurs at a time of solar maximum. So the sun goes through cycles that repeat every about 11 years. And we're entering what's called the solar maximum, where there's more activity on the surface of the sun. You might see sunspots, which are little dark spots on the sun, which represent cooler regions. There might be more prominences, which are like little gas loops that sort of pop up from the surface of the sun as well. And so we might be able to see some of that during the eclipse because there's potentially more activity for the sun at this time. And this eclipse actually happens to be a longer eclipse. So the 2017 eclipse, I think the maximum totality was a little over 2 minutes. There are some places for the 2024 eclipse that will experience more than 4 minutes of totality, which is one of the longer time frames. So that makes this eclipse sort of extra special. Another reason why eclipses in general are really special and cool is because they give us a connection to our community that we don't experience often. They connect us to our history, not only our local history and our personal history, if we've seen eclipses before, but also to history throughout the world. Eclipses have been recorded through time immemorial in various cultures all over the world. So we can connect to historical events, to cultural interpretations and celebrations of eclipses, and really, experience sort of another aspect, another connection to our global community. In addition, this is a positive shared experience, and we don't often get those, especially one on this scale. You might, if you've gone to a music concert or a sports game, those are powerful, positive shared experiences, but those are on smaller scales. This is taking place over millions and millions of people will be watching this. So that kind of shared experience can be a really awe-inspiring and powerful thing. I really like this quote from Emily Levesque from her book, The Last Stargazers. And she's an astronomer, I think at University of Washington, but I'm not 100% sure on that. But she says, an astoundingly perfect black void sat where the sun had been surrounded by a jagged white nimbus of light that nearly brought me to tears. It felt like the planet itself had been put on pause at this particular place and moment in time, a frozen moment of look. And I think that really sort of illustrates just how powerful the experience can be for people, that it does feel like time kind of stops for a minute. And it can be an emotional experience for a lot of people as well. Okay, so those are some of my takes on why eclipses are really exciting experiences. So let's get down to sort of more of the logistics. How do we safely view eclipses? So before I answer that, I need to make sure everyone understands that we should never look directly at the sun. The only time that that is okay is during the total phase of the eclipse. And that's it. That's the only time that it's okay to look at the sun unaided. Otherwise, never look directly at the sun during an eclipse or regular days. Sunglasses aren't safe enough. You need proper protection. So the main way that a lot of people think of for viewing an eclipse are eclipse glasses. And this could be in the form of actual glasses or also these just eclipse viewers, which you just hold in front of your eyes. Some people like these better because, especially if you have glasses, it might be easier to view with these rather than trying to fit these over your glasses. So for participants today, I have both. You can decide which one you want. They're both perfectly approved and useful tools. So basically what these are is just cardboard with a special filter in the middle. This filter is such that it basically blocks out over 99.9% of the sun's light. So if you actually hold this up to your eyes, you can see nothing except the sun. And if it is sunny outside, I would encourage you to try it. Go outside, don't walk while you're looking at this, just stand still, put it over your eyes, and then look at the sun. So that's really important. Do not look at the sun first and then put this up. Put this over your eyes and then look up and find the sun. You need to make sure that you get these from approved vendors only. So there are, I mean, I would not suggest just going to Amazon, for example, because you don't necessarily know that you're getting the correct safety standard for the glasses. So whatever glasses you get, you want to make sure that it has this ISO stamp on it, 12312-2. So this is the international safety standard that is approved for viewing the sun. These are approved, so you're fine there. You can find them, so universities like us often have them to hand out, museums, planetariums, some libraries or parks, national parks might have them as well. So these are all places that you can look to see if they're giving them out or selling them. It is getting close to the eclipse, so if you're looking to buy them, you need to do it absolutely now, like right away. And try, look around. You should not be, if you're asked to spend 10 bucks on a piece of cardboard, that's a bit exorbitant. I mean, I got this for maybe $1. So hopefully you can find them with more reasonable prices, or for free, like we have today. Okay, so if you don't have eclipse glasses or you want to view the eclipse in other ways, if you know anybody who is a welder, then buddy up with them, because welding masks are also safe for viewing the eclipses. Now, they do need to be a shade 13 or 14 only, so nothing less than a shade 13. And you do not want auto darkening masks because it might not darken fast enough when you're looking at the sun. So something that is shade 13 or 14 for a welding mask will be proper protection for your eyes. Other ways to view the eclipse are indirectly. So the fancy term for this is a pinhole projector, but really all it is a piece of paper, or I used a paper plate. This person used a Solo cup. You can get them fancy ones, like an index card that you punch a hole through, anything like that. And these are real easy and cheap to make, of course. You punch a hole through it and you take it outside, you let the sun shine through the hole that you've made. And as you can see here, there's a little circle of light that appears if you project this down onto the ground or the wall or something like that. That circle of light is actually an image of the sun. And so it's a circle because the sun appears as a circle to us. But what you'll notice as the eclipse progresses, as the moon gradually covers the face of the sun, that shape will change to a crescent shape. And it will get to a thinner and thinner crescent as the eclipse progresses. So you'll see on that piece of paper that circle of light change to a crescent shape and then increase from there. So this is an indirect way to view the eclipse. Now, of course, if you don't want to get a piece of paper or anything like that, you don't need to. You just go outside, interlace your fingers so that you have like a crosshatch pattern, hold that up and let the sun shine through it. You could look at the leaves on the trees, the sunlight coming through the leaves on the trees, which hopefully we'll have leaves on trees by early April in Indiana, but no guarantees. But the leaves, or the sun shining through the leaves also shows the crescent shape. Anything with small holes. So this person, I found a picture of somebody holding up a wicker hat or a straw hat. You could get your colander from your kitchen is a great one to take outside. Anything with small holes, you'll see the circles change to crescent shapes as the eclipse progresses. So this is the best and cheapest and easiest way perhaps to view an eclipse safely. If you are at a place where there is someone set up with a telescope or binoculars, they will have a special filter for their equipment as well. And so, you know, it'll be safe to view as long as they have their filters in place. One thing you do want to do to make sure with your Eclipse glasses is always check them before you use them to make sure that there aren't any scratches or punctures, because if so, then you could get light then shining through that could damage your eyes. So always hold them up to just a regular light source and make sure you don't see any light coming through. And then, you know, they should be safe to use. Okay, let's get down to more of the basics here, the logistics. So as I said, I'm going to talk about what to expect for the eclipse here in Gary, and then also down in the Path of Totality in Indianapolis. So in Gary, Indiana, we're in Central Time. So these times are for our local time, Central Time. We will see 95% partial coverage of the sun, which is a significant partial eclipse. You will notice something is happening. It starts a little before 1 p.m. with maximum coverage at 2:07 p.m. And then the eclipse finally ends about 3:20. So it's a couple of hours. And these times you can get from timeanddate.com. This is a great source, and it's listed on the handout that I give you in the resources. You want to, once you pick your location, wherever you're going to be, you want to go there and get the exact times, because they can predict these times down to the second for your specific location. So you definitely want to get those specific times for wherever you're going to be. And Time and Date is a reliable source, so I definitely recommend doing that. What can we expect for a partial eclipse? Well, for 95% coverage, at the very beginning, like right around 1 p.m. when it's just starting, you're really not going to notice anything. But as the eclipse progresses to get to higher and higher coverage, you will start to notice that the lighting is changing. And I like to describe it as it starts to feel like it's a cloudy day, but it's a blue sky and it's a clear sky. So it's sort of an eerie feeling that the lighting is dimming, but the sky is still blue. And so you will start to notice that, although it is a very gradual occurrence. As you get closer to that 95%, you might notice that shadows start to sharpen. And so normally shadows sort of have a fuzzy edge, but they might start to appear more sharply defined. And that's because a lot of the ambient light, the sunlight that's being scattered around in our atmosphere has been reduced greatly. And so you're getting more the direct light that's still coming from the sun to create these sharper shadows. If you pay attention, you may notice that animals and insects start to behave as though it's twilight. They might start to, the birds might start to chirp more as though it's dawn or dusk, something like that, because they're responding to the changing light as well. And then it might cool off. As again, that shadow is passing over you, the temperature might drop slightly. And so you might notice that as well if you're, attuned to the environment. Something cool about this particular eclipse is that we may see Venus. Venus is offset from the sun at this day and time, and it's bright enough that we might be able to see it even during a partial eclipse. So I would suggest trying to look away from the sun sometimes to see if you can spot Venus. It would be sort of probably down into the right of where the sun's location would be. One important thing, though, is to make sure that at all times during the partial eclipse, you keep your safety viewers in place. So either you're looking through the pinhole only, or you always keep your safety glasses on. There's no time when it is safe to take them off. Always keep them on. Okay, now let's get to the total eclipse. So I'm giving the times for Indianapolis. As I said, make sure that wherever you are going to be, you look up your specific times. They will be close to these, but not perhaps exactly the same. So in Indianapolis, we're on Eastern time, and the eclipse will start just before 2 p.m. with totality beginning at 3:06, and for Indianapolis, it ends at 3:09 and 54 seconds. So Indianapolis has almost 4 minutes of totality. The further you get into the center line, so that's what these sort of yellow lines are showing on this map, the more time of totality you will have. So on the edge, it might only be 30 to 45 seconds, but in the center, you can see in some places it'll be over 4 minutes. So that's really, something to think about if you're still trying to plan where you're going to be. Okay, what to expect for a total eclipse? Well, during the first hour-ish, again, it's like the partial eclipse. Not much is noticeable at first, and you want to view the partial phases safely. As you get closer to totality, you're going to see some of the same things occurring that we would for our significant partial eclipse. Changing light, sharpening shadows, listen for the animals, feel the weather. But a few other things happen just prior to totality that's special to the total eclipses. One is a phenomenon called shadow bands. So something that happens as the moon is passing in front of the sun, and it's getting, just a few seconds before totality. Some people have seen sort of ripples of shadows passing over the landscape called shadow bands. And this is due to refraction in the atmosphere from that sort of more directed, thin beam of sunlight. And so those are elusive and they don't happen for that long. It's right before totality. So it's something to look for. Another thing to look for is a phenomenon called Bailey's beads. So this is where on the edge of the moon, because the moon is passing in front of the sun, the moon is not a smooth surface, right? It has craters and hills, valleys, etc., just like the Earth does. And so the light that passes through those hills and valleys appears as like a pearl necklace around the edge of the sun. As the last beams of light are shining through the moon's craters and valleys. So look for those Bailey's beads. And then the very last of those beads is this diamond ring effect, which is shown in the image here, where you have this last burst of light shining through that last crater in the moon, and then boom, it's totality. So this is sort of the marker that totality is imminent. What happens during totality? Well, once the moon completely covers the sun, you can take off your eclipse glasses, or if you can directly look at the sun with the unaided eye. This is the only time when it is okay. So you can view the sun directly without any aids. And what you will notice is this sort of glow around the sun. It might be a wispy, billowy kind of glow, which is the sun's corona. The corona is the outer atmosphere of the sun. It can only be seen in visible light during a total eclipse. And so this is actually one of the areas that scientists like to research during a total eclipse, is to view the corona in visible light, because most often we view it in other wavelengths of light from space. So the corona is a real neat thing to see. It's bright, but it's no brighter than the full moon would be. So it's safe to look at without any protection. Some other things to look at is actually, it might be hard, but look away from the sun for a little bit. Venus, as I said, is up. Actually, other planets are up at this time too. We happen to be lucky. Jupiter is also up, as well as Saturn and Mars. Now, Venus and Jupiter, you should definitely see, because these are the two brightest objects in the night sky after the moon. And so those should be fairly apparent. You might also see some bright stars. Bright stars can appear in the sky as well, so you will want to look away from the sun to see if you can spot those. If you have a view of the horizon, then I would suggest looking out at the horizon as well, because you might see the edge of the moon's shadow and a glow beyond where the sun is, of course, still shining. So it's almost like a sunset, but it's a sunset in 360 degrees. So you'll see this glow off in the distance. And there may be more things to experience as well. One of the things I think is fun to experience is just the reactions of people around you, and seeing like what are they taking in. Some people scream, some people gasp, some people go completely silent and are speechless. It covers the whole spectrum. So that's kind of a fun thing to take in as well. The main thing to do is just enjoy the experience. Don't try to be snapping pictures the whole time, or, if you have a very chatty friend who's next to you and you really want to be silent, make sure they know ahead of time, because you really want to be able to enjoy the experience for yourself, because it really is a once in a lifetime thing for a lot of people. Once the diamond ring appears again, that's the end of totality, and everything happens in reverse. So you'll see the diamond ring. That's the clue to put your safety viewers back on, because you need to keep your eyes protected. And then you'll see Bailey's beads and the shadow bands, and then the light will start to brighten, and animals will come back to their natural state, and we get back to reality. So you have, that last bit of time to sort of process what you've seen and experience the rest of the partial phases. Okay. I always get the question, what if it's cloudy? Because astronomers are subject to the weather. We have to abide by Mother Nature here. And you might, especially in Northwest Indiana, it could snow in April, right? So we don't know what the weather is going to be like at that time. But don't despair. There are a couple things we can do. One is, if you have flexibility, if you are able to drive and you're not stuck to one specific location, then pay attention to the forecast ahead of time and see if you can be flexible about driving to an area where the forecast looks more favorable. So, that would be my first suggestion, is to try being flexible so you can move. If you are confined to where you are, if you aren't able to drive anywhere else, then you can watch a live stream. This is actually, it sounds like, not that exciting, but it actually can be quite exciting still, because there will be many places that live stream their eclipses. But not only do they live stream what's happening in the sky, a lot of them will live stream what's happening on the ground with people. So you can still vicariously, but you can still be part of that experience and share in the awe and wonder that people are experiencing as well. And then you can see the eclipse happening, which is also very cool. Often, even with clouds, you can still experience the changing light. So this is a series of photographs taken by an eclipse photographer, whose this particular eclipse was obviously clouded out, but he took photos of the environment, and you can see that over the time, that dimming of light was still apparent. And so that is still something that you can experience if the clouds get in the way. And then, of course, prepare for a future chance. So the next total solar eclipse to touch the lower 48 United States is not for 20 years. So August 23rd, 2044. So it's quite a long time. There are other eclipses around the world before then. So if you're into traveling, you could combine a vacation with an eclipse tour. But if you are in the United States, you'll have to wait 20 years until you get the next chance for one. All right, a few other tips. So one tip I have is, once you look up the times for your location, if you are in the path of totality, you'll know exactly when totality begins and when it ends. I suggest setting a timer for that length of time. So if it's 4 minutes and 1 second, set your timer, so that as soon as totality happens, you click setting the timer, and then you don't have to worry about continuing to look at your watch. or thinking, you know, when, especially if you're with someone who's a little bit nervous and really, you know, is afraid about eye protection, you'll know, okay, we have this amount of time before we have to put our eye protection back on. We don't have to worry about looking at our watch the whole time. So I would definitely suggest setting a timer. Another tip, consider traffic. Many places in totality or just outside totality are spouting the hashtag Take Tuesday Too, because the traffic, as was learned from 2017, is going to be significant, more than usual. Unfortunately, too, in Eastern time, the eclipse ends about 4:30, which coincides with regular rush hour on a Monday. So that's also going to be a compounding factor. So if you are able to stay with a friend, or if you booked a hotel and you can stay into Tuesday, that might alleviate some of the traffic congestion. Regardless, whether you decide to leave Monday or leave on Tuesday, prepare for extra long drives, okay? So make sure that you are not expecting, you know, if you're driving down from Gary to Indianapolis, it normally takes maybe 2.5, 3 hours, expect probably double that coming back, because the traffic will be heavy. Also consider your location. Where do you actually want to be? So you might pick a town or a, you know, a particular place, but what venue, what specific location in that town will you go? So one of my tips is for observing astronomy in general is actually find an old cemetery. They tend to be public places, so they're open to the public. They have open views of the sky, and they tend to be quiet. So if you are not a crowd person, you want to experience this with just a few people or even by yourself, that might be a place to look into. But other places could be, if you have a hotel in the path of totality, you could just stay in the hotel's parking lot. You could go to a park. Public parks are fine. There are plenty of venues and universities as well that are hosting events. So Indiana University Bloomington is hosting an event. We have one in IUN. Museums and planetariums will also probably be hosting events. So those you will have to check ahead of time. Some of them may require a fee, so you need to buy a ticket. Others might be just open to anybody and you can just show up. So plan ahead for your specific location where you want to be. And think about things like bathroom and food access. Again, this is over the course of a couple hours, and then everybody's going to leave. So you have to think about, you know, do you need access to a bathroom during that time? There are going to be a lot of crowds. Will you have time to get food, or should you pack an extra, you know, snacks or lunch or that kind of thing? So just make sure you plan ahead so that you can actually enjoy the eclipse rather than worrying about some of these things. Another thing you can do for viewing the eclipse is join a citizen science project. So there are several projects around where they encourage the public to download an app and participate in gathering data for the eclipse. So the one I am familiar with is Globe Eclipse, which is from Globe Observer. And so this is an app you can download, and it'll just record things like your temperature, perhaps the wind, the light from the light sensor in your phone, and then it'll upload those to their data center to be analyzed by scientists who are looking to understand more about, you know, how lighting and all affects, how these eclipses affect the atmosphere here on Earth. So that would be a fun thing to do if you're interested in as well. And lastly, once again, just a reminder, take it all in. You can ignore everything I've said here as long as you are just present in the moment and experience it however you want to for yourself. That is really the key thing, so that it becomes a real memorable moment for you. Okay, so I'm going to end in just a minute. I want to put in a plug for my colleague, John Eros. He is giving a cure talk in a couple of weeks about his experience photographing the 2017 solar eclipse. So he traveled to Totality in 2017 and had a whole setup with his camera and everything to photograph the sun with special filters and all that. And he encountered certain obstacles and things along the way, but he was ultimately successful in photographing the eclipse. And so he's going to talk about his experience, show you some of his photos, and I imagine he'll also talk about his plans for 2024. But that might be interesting for you as well, as sort of a different take on the plans needed for an actual photography session. Okay, and then I have a list of resources. So these are basically all on the handout that I've got or that will be emailed. And there are a few that are like the Eclipse glasses vendors and the live stream links. These are within the eclipse.aas.org, the American Astronomical Society website. So if you go to this link, then you'll be able to find these sources as well. Also linked in the American Astronomical Society website is the greatamericaneclipse.com. So that's another great resource for finding more information about this particular eclipse. And I've listed my email there, so I'm always happy to answer questions if you have any as well. Okay, so that concludes my talk. So thank you everyone for coming. I really appreciate you taking the time here. And I'll turn it back over to Tatiana.
Thank you, Jessica, for teaching us this adult education in senior university, the Great American Eclipse in You class.